We're going to look at 1 Charlie, identify basic facts about the network bandwidth management. And as you can see, you definitely need to get a 70% on the test. That means you can only miss 12, and you need to get 28 of them correct. Let's go on. We have the AFSC application. Biggest thing is you're going to have to deal with bandwidth when you're dealing with multiplexers. So we're going to look at the bandwidth allocations, network infrastructure, transmission media, carrier system concepts, and hierarchies. So let's get to the first one, bandwidth allocations. We got conventional, we got demand assigned, dynamic, and time of day restrictions. First one up is conventional. The biggest thing about this is it has to be fixed. You're going to get 64K for each user, but just remember, if you're not using it, you lose it. So you can see in this diagram here, we have 4 64Ks for a grand total of 256, and that's your total bandwidth. But if you're not using it, in other words, you're idle, it's wasted. So the next one we got is demand assigned bandwidth. This is going to be an exact amount for each user, but there is a possibility it can flex for you. It's just like the internet. So in other words, if I am asking for, right now it's my AT&T, we're going to have 25 up, 5 down. I think that's the way it works, or is it? Yeah, 25 down or 5 up. I can't remember. Anyway, that's what I pay for. Is it possible that I can get more? Of course, it's always possible. Can I get less? Well, that's where, how many people are on, and just like you guys are in the dorm. So it's one of those, wait and see things. So we look at demand assigned on this one. We got 64K, 9.6K, 56K, but there's still 126K available. So, and for a grand total of 256. So if you're not using it, it's going to go into a pot, but if you need to get more, there's a very good possibility that you're going to be able to access that. That is demand assigned. So next up we have dynamic bandwidth. This is combining everybody, but the problem you have with that one is you could exceed your bandwidth, and this is where the likelihood of you having to wait for time to show up now comes into play. In this case, we've got assigned 2 64Ks. However, we got 2 128s, and that's a big problem. The 128 exceeds the 256 output. So at this particular point, even though it's dynamic, you're going to run into some major problems. So that's the problem what you have with dynamic. When we look at time of day restriction, I always like to relate this to, if anybody's ever seen the Lone Survivor. Well, with the Lone Survivor, in order for them to contact base, they had specific time frames where they were allotted, and they had priority on that. No one else could get it, but only them. So that is the biggest problem that you have with time of day restriction, because if you don't use it, it's no longer there. So that's the biggest problem. So the next thing we look at is network infrastructure. Okay, we already talked about having 2 or more users with multiplexing. Well, this one's going to involve 2 or more exchange, and the users that are in there could be massive. So this is where basically the internet, in how we look at putting everything together along a transmission line, and we consider it, when we look at bandwidth, we got to figure out how much we're going to need within that server area. So let's take a look at the network infrastructure. So we got 2 here, is the EIA 232 Charlie and the EIA 530. You're going to be seeing the 530 pop up on the NSM for us today. when we go through the tech order. So the EIA 232 was back in the day when computers started becoming prevalent. And when I say prevalent, is we had only X amount of capability. And this one where the old 56K dial-up came into play. How many of you are familiar with the 56K dial-up? Oh yeah, go ahead. Ah, what'd you do in your last job? Okay. Wow, that is ancient. Yeah. Yeah. Either hop on board or get the heck out, right? Yeah. Well, anyway, this 56K, for those of you who don't know, one of the worst things could happen is you could be on the computer getting ready to do what's called sniping on eBay, because that was big right around that time. It would take probably 10 to 20 seconds to download an eBay page. And when you finally bid and someone calls you, it knock you off. So you wouldn't be able to bid. It's one of the most frustrating things ever. But now you learn with eBay, you just go ahead and make your bid. If you win it, great. If not, oh well. Now, we do have EIA transmission lines, and you guys have been dealing with this pretty much over the past many years. We have two types. We got balanced and unbalanced. The first one is balance, and the biggest thing about balance is you got a twisted pair that you're running this information down. Now, what makes this so different than anything else is because on one line it's a waveform. The second line is 180 out of that waveform. So when it gets to the distant end, it puts it back together, and because all your transmissions lines generate noise, depending on how far it is with twisted pair, when you put it together at the distant end, you fold the other one back on itself and it's able to cancel the noise out. Now, how does that work? Well, the biggest thing I can tell you is if you've ever heard of noise canceling headphones, it takes the outside stuff that you're hearing and it puts it together with the inside part, and it's always 180, so when it puts it together it flips it back out and it cancels the noise. Now, for someone that has seen that particular thing, the closest thing we can relate it to is the signal plus noise to noise ratio check on the PRIC 113s. You guys should be familiar with that. With the PRIC 113s, what you do for that signal plus noise to noise ratio is you take the signal and it has the noise, you run it through a filter to cancel the signal out, and then you put the noise, and what happens is your signal is at one level with the noise, and then just the noise should be down here. You should be at least 10 dB of separation on it. If it's more, that's golden. So that's two references with the balanced line and how we're able to cancel out the noise. So the next one we have is unbalanced. Now this is your coax cable. And the bottom line on the coax cable is if you got a good communication ground, not to be confused with your electrical ground. Yes, they are separate. A lot of companies nowadays actually connects it out on the ground for your electrical, and that's a no-no. You should always keep those two separate. In fact, the tech order for grounding, I think it's the 00 series tech order, specifically states you got to have one ground for communication and one ground for electrical. And you also have to keep them separate approximately 10 feet in order to keep from what's called eddy currents happening. And the biggest fallacy about that too is if you don't have them separate, if you get a lightning storm and it comes down there, you run the risk of it running back in on your systems and, you know, blowing up your devices, like your router, your, you know, fill in the blank, anything that's communications, Wi-Fi, you name it. And I've had many a TV and VCR blow up in my day because I didn't really understand it until I got into the double-aught series tech order. Once I realized that, then I started separating out, and I never run into a problem when it's lightning around here. So let's go past the unbalanced line and look at the EIA characteristics. Doggone it. I thought I had it in front of me. Anyway, what EIA characteristics means is the DB connections. Now, on the back of your NSM is a DB connector. I think it's a DB50. Now, I used to have DB9 pins for our printers, then it upgraded to DB25. Now it's all, what, wireless or Cat5. So you can see how technology has changed, but we still work with the D connectors. Now, if you had the old netbook computers that if you were issued that at the beginning of our course, you would notice that they do have D connectors. If you have one of the older laptops, you can use the D connectors to give yourself a extra monitor if you wanted to. So it has its benefits with DB connectors. So just you just might come along it, and you will come along it tomorrow when you guys are playing on the NSM. Next up, we have the EIA characteristics. This is just giving you an idea that it is very possible that you might come across something called negative logic. In other words, a high is actually a low and a low is actually a high. I have worked on equipment that does have the negative logic, i.e. the OJ314. It always represented a high with a negative voltage and a low with a positive voltage. It was one of the craziest things I'd ever seen. Now we're looking at the EIA 530. So we've gone from the 232 Charlie and some of its quirks. Now we're looking at the 530. Now the 530 is the upgrade to the 232 Charlie. Now, if I'm not mistaken, this particular EIA is an actual electronic industry, something other, I can't remember what the A is for, administration. These are groups that make recommendations to what the company should go to. And why is that? Well, when we started getting these computers in left and right, it was really hard to figure out which one was the best. Because if you had a, believe it or not, compact computer, you had to make sure that you bought a compact printer. You couldn't mix a brother printer with it. You could only use a compact printer. So they started coming up with these things to get the interoperability. Now what is it today? Well, if it wasn't for these particular types of groups for electronic industry, you would still have this problem. So now we have where an Apple can work with a PC and vice versa. Android can work with an Apple. The long list, everything can work with everything else. So that's the whole idea when you're dealing with these EIA standards. So next up, we have what's called network infrastructure. We have a DTE and a DCE. I brought in pictures just so that you could see it. DTE, the T, Tango, is the terminal. It means it is the source and the destination. So everything starts with the computer and ends with the computer in this case. With DCE, it's the communication device that goes from the computer to that communication device and then out the distant end. So a modem would be one, a router modem that you normally get nowadays with your Wi-Fi. So those are some examples of a communication device. There are 4 types of transmission media. We go through twisted pair, coax cable, fiber optic, and wireless. Twisted pair, obvious reason. Nowadays we have Cat 5, which is now being replaced with Cat 6. It is crazy how they end up working. So what's the difference between a Cat 5 and a Cat 6? Anybody know? Ah, good. Very good. That's exactly what I wanted to hear. Yes, that is very true. So in other words, you're twisting it more and getting the speed that you want to increase as well. That's the difference between the two. There are some, I think it's called plenum, which has shielding around it, which is even better. We have coax cable. Go ahead. Oh, I thought it was... Okay. I was under the impression it came with shielding. Okay. No, that's all right. Sometimes I need to be corrected on that. That's one of those I need to do some more research. I kept thinking it was always because it came with a shield around it. You know, the little aluminum foil that comes in those things. Learn by my mistakes. Okay, so coax cable, a little bit different. This one has a center core, the outer core is shielded. If you have this particular cable, it's called unbalanced. Now, the key thing about this particular unbalanced is you need to have a good ground with it. If you don't have a good ground, you're going to get noise all over the place, and you might not have that good of communications with it. Then we have fiber optic. This is using light to put all your signals on. Everybody aware that light is a form of RF. It's on the upper end in the terahertz. Just like you can hear RF, and that's above the 3K hertz. But fiber optic is what most people are starting to go to. I'm still waiting for it to come in our lovely so-called town. They've got half of it done, but left us out to hang. Heck, my mom in the middle of nowhere in Kentucky has fiber optics, and she's got some awesome speed on hers. She doesn't live anywhere. I live in a city. What's going on with that? Wireless, obvious reasons. No wires. Whole idea behind it is you don't have to dig to put cables in. It is becoming the most popular device, but there are problems with it just like cables are. Cables are increasingly becoming more and more expensive to put in the ground, whereas wireless over the air, it doesn't cost anything to put the cables, but it does have a backlash because I think it's the NTIA wants to start cutting down some of those frequencies to where they can fit more frequencies in there. What does that mean? Well, if you got a 25 kHz band pass, they want to cut it in half to give you 12.5. Pretty soon it will be 6.25 for that band pass. So it's getting crazier as we increase our technology. We have something called carrier system concepts. We have a DSU and a CSU. This one, the DSU, is considered between the routers of the customer. Now, the big thing about this is you'll see that it says RZ bipolar. It is the user side of the network. Oh, look, notice it says AMI, alternate, mark, inversion. Wonder where you heard that. Anyway, the DSU is the customer side. It's going to, when you call up one of your communication companies, you want to take a look at the customer first, unless there's any hint that it might be this, the network side. because they're the one calling going, hey, I got a problem here. So they're going to ping that distant side and do a loop back just to see if everything on the customer end is working fine. The next one is called the CSU, not to be considered as the customer service unit, but a channel service unit. This one's on the network side. You'll notice it says RZ bipolar with zero suppression. That is self-clocking. Also alternate mark inversion. So CSU network, DSU customer. Just to make sure you guys got that straight. Then we have something called hierarchy. Now this one, the way they looked at it is you've got a voice channel at 64K. Then you put all of those 24 channels to get 1.544 megabits per second for a DS1 or a T1 line. Then you start adding these different multiplexers in line to get our T2 and our T3. If you don't have enough bandwidth, you start adding more. That's one way to look at it. So when I show this picture here, you can see that our T1 multiplexer has 24 channels. When it comes out of that 24 channels, it says 1.544 megabits per second. We have the T1, and we have 4 of those T1s going into the next multiplexer. So when it comes out, it should have 6.312 megabits per second. That's what makes a T2 line. In order to get a T3 line, you got to have 7 of those T2 multiplexers. So you can see this is like at the bottom of a triangle, working our way all the way to the top to get more and more multiplexers in there. So we looked at bandwidth allocations, network infrastructure, transmission media, carrier system concepts, and hierarchy. And along that way, I learned something. Any questions? All right. Let's go on to the next one. 1 Delta. So that was 1 Charlie. This is 1 Delta. Identify basic facts about the principles and capabilities, limitations of multiplexing equipment. You're going to work with them. In this case, we're going to be looking at the nodal satellite multiplexer, better known as the NSM50. We're going to look at the purpose, functional description, operational characteristic, and NSM configuration. So the first thing we look at is the purpose. Just remember, if you can multiplex it, you should be able to demultiplex it. It doesn't make any sense to multiplex with encryption in it and not demultiplex it with no encryption. Doesn't make any sense. Why would you do that? For the NSM, you'll see our max data rate is 52 meg. We'll get to that in just a few. It has 2 operational modes. We have legacy and enhanced. Legacy being just like me, I'm an old fart. Enhanced is like you, which is a new farts. So there you go. New versus old. We do have cut sheets, so you're going to get to be very familiar with them when you get in the NSM lab. This is our input ports and data rates. You can see that we've got basically 4 different styles of input ports and different max data rates for them. On the back of our case is where the D connectors are. You can see the color code and where each one of them are. Now the difference is our CDIs. They're a Canon plug. Everything else is closely resembles, I shouldn't say closely, is a D plug. The NRZ is the one that your guys are going to be focusing in on. Now from what I understand, looking at the TO, no one can actually say, hey, bam, bam, bam. You cannot mix and match with these, but you can mix and match once it gets to the multiplexer. So you can either run NRZ or you can run CDI, or you can run T1E1, or you can run the two hissies. So just to give you an idea on it. Now we're going to be looking at this extract here in a few seconds as soon as I get through this. So go ahead and start pulling it up, and we'll end this through the summary. We're looking at the NSM, purpose, functional description, operational characteristics. So let me pull up the NSM. This is what it looks like. Does everybody have it pulled up? Who doesn't have it pulled up? I'll wait on you. All right, let's go through it. Now, this is a satellite modem. You'll see that it says Vertex RSI. Those are the individuals that, or the company that made this. You can see that we do have warnings. You do have cautions on it. I'm just going to casually get down to, I think it's 1.1 scope under introduction. You can see it's just giving you an idea of what it is and what it interfaces with. But we don't get into the good stuff until we hit 1.3. Remember, we talked about functional descriptions and purposes and all that? Well, this is the start of it. You can see that where we talk about how we're going to multiplex and what it is that we're going to multiplex it to. You also notice in there it has something called a GUI, G-U-I. That is how we are going to program our NSM. We're going to do loopbacks with it. Just to give you an idea, we're going to use something called a BERTS, or in our case an HST 3000. Here's the control interface. You can see we have RS, that's the committee doing recommended standard for 232 or 422 DTE. Notice how everything's transferring to this piece of equipment that we learned earlier, or we went over earlier. DTE meaning the terminal. It's acting like a computer. You'll see Charlie where it says GUI. That's what we're going to use. Can't even remember the doggone name of it. The user interface. So that's the last two. I can't remember what the first one is. So next up we have external signal interface description, starting with Bravo. You'll see we have legacy and enhance. And the easiest way to find out what the max data rate with these things is you got to look at legacy and enhanced. Well, first of all, I wouldn't even look at legacy because I know it's older equipment. It's not going to go as fast. So I'm going to look at enhance and notice that whatever the largest number is, that's my max data rate. We look at Charlie when we have the T1E1. Notice it says bipolar. T1 says alternate mark inversion with Bravo 8 Zulu Sierra. What does it mean? It means that this is a North American format. If you look at number 2, E1 is a Japanese or European format. Now you don't need to know that. You just need to know that we can do T1E1 on this particular piece of equipment. We also know that you got to do NRZ on it. We also need to know that you can do CDI. CDI has both legacy and enhanced mode. All we got to do is look at the max data rates on those, the largest number. We have the last one, which is the high-speed serial interface. You'll notice Echo says EIA 530. We just went over it, didn't we? And it also says EIA 613. It's a faster cable. You'll notice it says 52K in 8 kilobits per second increments. Gotta love it. Oh, look. F. Secure order wire data signals must be unbalanced NRZ. We just went over that, didn't we? And you'll get to run the GUI on a laptop that's on top of the case. Have fun with it. Here's your purpose of equipment. That was one of the highlights on our past Delta here. This is an awesome picture. Pretty much tells you, hey, I got all these items coming into the NSM. We're going to send it out up to the satellite. The satellite's going to relay it back down to the Earth satellite, through the NSM, and then back out again. Picture's worth 1,000 words. If you're having problems trying to find out how many ports there are, right here it is. You got 12 NRZ, 2 HISSIs, 6 T1E1s, and 6 CDIs. You can see how we demultiplex it and multiplexes it. Network configurations. Now, I'm just highlighting this because I thought this was probably one of the best non-nodal ideas in network configurations. Gives you an idea how things work. Again, picture's worth 1,000 words. You have user port interfaces. This is where it gets down into the nitty-gritty of telling you what you have. 12 balance means it's going to run off of a twisted pair, just to give you an idea. You have T1E1. You can see it's 6 bipolar. Where have you heard that one? You got 6 group modem with CDI. You have 2 HISSI, high-speed serial interface. And that was on page 2-5. Order wire. You're going to hear that a lot when we get to the TISR. Order wire meaning it is a auxiliary channel that maintenance gets to use and does not affect the mission traffic, which is where everything's being multiplexed. This is the NSM on the rear. You can see that we have a DB9 plug, a DB25, a DB62 on there. So it just gives you an idea what we are going to connect with. A DB44, wow. This is the front panel. This is where all the LEDs are lit up. This is your on and off switch, your fan. Mostly everything should be green unless you got an error. That's one way to find out whether or not your NSM is working as advertised. This part right here is the first part about the GUI on 3-3. It's just double click on the NSM icon. Let me do this right here. You're going to see that on the laptop that you're going to be programming it in. Then you're going to come down to this tab that comes up once everything is kicked into gear, and you're going to make a selection and get right into the GUI. And I think this is it. It's pretty simple. I think there's 20 some odd pages with it. So there you have the NSM. Let's get to 2 alpha. We are burning right through it. Sir. Yes. All tech orders or tech manuals will be provided. Normally it's a the electronic version. Excuse me. There is C's and D's with it. You have the option of having the electronic version or the paper version. Now the paper version, hang on a second. The paper version is that big. It's 11 by 17 and very large. It does have some items on it that the electronic version does not have. We'll go through it when we get to it, and hopefully I'll remember to point that out to you. So that's what you have in order to take the tests, both the TISR-TO, the NSM 50 Tech Manual, electronic C's and D's, or the paper ones. Your choice. You're welcome. Okay, next up we have 2 alpha. This is identify basic facts about capabilities and limitations of the bit error rate test set, BERTS, not to be confused with Bert and Ernie. We're going to look at the AFSC application. When you are dealing with items like the multiplexer or routers or anything like that, there's a very good possibility that you're going to have some errors show up. Now, with using a BERTS, you're going to be able to find out what is an acceptable error rate versus what isn't an acceptable rate. It depends on the equipment and what to look at. With the basic BERTS description, we're looking at something that is very easy to get out of the study guide workbook. We also look at the HST 3000 operation. Most BERTS operate just like the HST 3000. So we're just giving you very, very basic information. This will not be available to give you on the test. Why? Because I think in the study guide workbook it might be a page, maybe a page and a half. So on the basic BERTS description, the big thing is performance tests, loopbacks on a system just to figure out if the signal quality is good. So it does look at receive and transmit patterns, looks at the errors, and will give you an idea of what's happening on the line. You can look at it either alone or alongside the traffic that it is used with. We look at the HST 3000s. Now, you guys are probably going to go, well, this equipment is old. Well, that might be true, but we purchased this back in 2010, and it's working just fine. Back then, it was $5,000 for one. You can get this off of eBay for $3,000 now. You're going to find out it looks almost brand new except with all the fingerprints on it. It takes some airman abuse, I guess you could say, where you guys use it a lot. Every now and then it drops. Luckily it doesn't break, or at least we haven't seen one break. We've seen it what we call bricked, where the programming on the inside just takes a dump. We send it to the manufacturer. We're waiting on it to come back to us. There are newer models out there, but it still does the same thing as the newer models. So we look at the HST. As you can see, we do end-to-end testing and a bit error rate testing. The biggest point that we want to look at with the HST is it does DTE emulation. It does DC emulation, and it does monitor, just like we were talking about earlier. Those are the 3 things that the HST BERTS does for us. So you can see this is a pretty quick and easy objective to look at. Remember, it's only it's very small. What the key points is, what is a BERTS? What's it do for us? And when we look at the HST, we do the 3 things, which is DTE, DCE, and monitor. Any questions on that one? Yeah, the last 3 objectives normally are. It's the first, actually the second objective, where it can be very overwhelming. Now it appears that Airman J is our technical expertise on our networks here, right? Well, you're probably one up on everybody on that one. You don't mind me asking how old you are? Okay. Anybody older? No one wants the voice. Okay. So what's your experience in the electronics career field? Okay. Anybody else have electronic experience? Okay. So Airman J is... Go ahead, Rodriguez. Okay. So Airman J has the more in line with what we're going over. Is there any questions? No questions? If I read this correctly, I'm going to go back up here again. You guys have lab from 12 to 4 o'clock tomorrow. If that is okay, at least that's what I'm seeing. So tomorrow at 9 o'clock, we will be going over homework.